Okay. Is this good? Yes. Okay, that's better. All right. So thanks and welcome all to the NLP panel. So I thought that I'd keep this relatively less structured than some other panels, and basically give everybody a chance to speak and more of a dialogue to emerge. But I thought that I'd start things off by talking about managing expectations around these technologies, because I think that that's one of the sort of interesting things about natural language processing. The technologies all have this enormous promise if they can deliver it, and indeed if they can deliver even some part of what they say that they might do, then that's still very useful. But how do we communicate that to people and say, well, this won't be fully accurate, but it may improve in accuracy in time, while still, communicating that it's a valuable thing that it's doing at the moment. So, Mara, do you want to start with this?
Thank you. Well, I think the most important thing about NLP is to, first of all, help the users understand the usefulness of having this type of information, because it has no meaning at all if we just say that, okay, we can find the subject, or we can find the adjectives, or we can cut sentences. This has nothing to do with the reality if the user cannot realize the usefulness of this piece of information. Why do you need a subject? Why do you need to know that this is a subject? So this has to relate with real needs. So if the user can understand the value in reality, in their everyday reality, then it's pretty easy then to help them realize that, okay, it's not 100% correct, but the value you'll get because you'll be able to perform this and this and this task, which maybe monetize what you do, then we have a case, I think.
So, Francisco? Yeah.
Yeah, we are focused very much on a fundamental aspect of this, which is actually understanding language. And the big problem there is twofold. First, it's not so easy to define what understanding actually is. Even if we try to sort of define our own understanding, I think it starts there already to be quite complicated. The other aspect is that the reference for this understanding are still people, and people are inaccurate too. So how are you going to figure out if your approach in doing NLP is actually accurate if the reference source is inaccurate? So I think that's the biggest issue with NLP in general, is that you are in this kind of fuzzy environment, and you have to, as you said before, you have to find the value for that. Yeah.
Okay. Yeah, thanks very much. So when you're talking expectation management, I think you also mean maybe with regards to your management. So for example, if you want to start a cool AI project in your company, it's important to set the tone correctly, right? So you want to sell it well because you want this project to happen. But at the same time, you don't want to oversell. You don't want to make raise unrealistic expectations. So for instance, if you want to do a chatbot or some sort of a, like we're working on is a conversational interface where you can speak to your phone and order something and ask questions. So you don't want to oversell. You don't want to say this thing is artificial intelligence, it can do everything. But also you don't want to undersell because you want this project to go forward. So, and it's also really important that these things go through because in many ways, like how well the stuff actually works depends on how good your data is. If you have more data, you can train much better algorithms and much better chatbots and all this stuff, right? So what you want to do is do like an approach, let's go back to this conversational example, like Siri did with Apple. They throw out a chatbot that doesn't really work that well in the beginning, but then they refine it over time. There's so much user data coming in, and this way you bootstrap the data, and at some point this thing is going to be really good, right? So maybe that's something.
So I think that also feeds into another point is, okay, so we can manage expectations, but then we can also do a lot to, I guess, design the application in a way that's going to be more fault tolerant, or design human processes around the application, kind of embedded in that kind of process so that it matters less if there are these mistakes. So, would you like to also say something about, you know, how we can do that? Like in the context of an application, you know, how can we basically add these design things so that the problem gets easier and the mistakes matter less?
Yeah, so one way to do it is to first restrict the domain. So instead of saying we're going to do something, let's say a chatbot that can answer every question, you just start with one very specific use case and one very specific domain where the users already know what to expect, right? So let's say it can do one type of question or one type of advice it can give you. And so the users roughly know what to expect. You can always roll out things first in beta so that they're even more warned that in the beginning it might not work that great. So these are some things that you could do, yeah.
Yeah, so now, Francisco, I know that you guys are working on things which are rather more critical than chatbots. So how do you make sure that, if you, you know, first of all, do you want to explain a little bit about what you're working on and then how you manage these things of accuracy in your processes and stuff?
Yeah, so we have a rather different approach. So we do, on one hand, use machine learning, but we don't actually model our use cases, but we model a semantic space that we define in a certain domain. And we actually don't train the system by using the use case data. So let me give a simple example. A customer, typically very large companies, they are having sort of the most expensive language-based problems currently, so they tend to be a typical customer nowadays. And they say, okay, we receive like 100,000 emails from customers every day, and we would want to filter out all the emails where they complain about something. And that's already the specification. Yeah? So what we do then is that we basically try to model the domain in which the customer expects to speak or so. And this is done by using reference information. So it's very much in the same way as a human actually learns to speak, is to learn a semantic domain that might start in school with some, let's say, general English, and then the person goes to university and learns about medicine, let's say. And we call that learning the semantic domain of medicine. And once a person has ingested things like textbooks, for example, about medicine, that person is able to understand medical language. And when this person then starts to work professionally, that person might start reading patient documentation. But the difference, as I said, is that we train on the reference information and not on the actual payload. And based on that, we try to find the right way of interpreting what is written in a piece of text and make it or represent it in a way that it becomes comparable to something else. That's the approach.
Okay, so basically you want to be averaging predictions over a lot of data, and you know, by doing that, it's less sensitive to inaccuracy on any one prediction because you've got a lot of information to average over.
Yeah, it basically learns the inaccuracy that might be there already in the data, and it behaves accordingly.
Okay. And Mara, what's your perspective on this as well?
We have a different approach as well. We don't rely on machine learning or deep learning to start the process, the whole process. What we do is we simulate how the human mind works when we try to understand something that we read or when we try to understand something that we hear. So actually what we do is use all the factors and any parameters that may influence the way we create assumptions step by step to understand something. So it has to do a lot with understanding, with human understanding. That's why we are very careful at specifying the domain, as the other two participants said. We define the domain. Our methodology can be applicable in any domain, but it's important to have a domain to specify it. And then text type is very important as well, because it has to do with the communication framework and the expectations of the audience or the reader. So we take into account all this type of information. So when we actually reach to automation, we have enough data plus reference material and stuff. So we have enough data for the machine to understand what it reads. And that's why we don't need to train it like in machine learning. Now we're integrating deep learning into our system, but we don't rely on it. We fit it in our methodology, which already works. So that's how we believe that we can minimize inaccuracies based on machine understanding.
Okay, so one of the ways that we can work with less accurate systems is if we can communicate to the users how the system works so that they can kind of expect what errors will occur or expect how the system will behave. But this is actually quite complicated with both natural language processing and with other types of machine learning technologies. First of all, because often the details of the system, maybe it's a proprietary technology and these are actually not communicated to people, but also if the users are less expert, then they're not that interested in finding out everything about how the system works. But is there sort of a balancing act that you have to provide for how much you tell people about how the system works? And if so, how do you manage that sort of balancing? Mara, do you want to start with this?
Well, from what we've seen so far, it seems that the customers don't really care how your system works. Especially if you start talking about technology or methodology or stuff, it gets a bit weird. So what they actually want to know is whether they're going to take 1, 2, 3, 4 steps and have 1, 2, 3, 4 types of results. This is what interests them the most. Of course, now with the GDPR, we'll have to eventually, become very transparent. But I'm not sure that this will help actually the customers in terms of improving their knowledge.
Yeah, so in our case, we mostly work on use cases where there is not a generic interaction with the user. So in fact, what we do, mostly at least, is to work in use cases where we have a business process, and within this business process, there are certain tasks that are need to be done by humans currently, and things like detecting email where people complain about something, or annotating business contracts, and extract certain facts out of that. And this tends to be very boring for people. So although, as I said, people are not perfect in the first place, but they get even worse if you oblige them to sort of do repetitive, boring work. So the results get pretty poor. And what we try to do is, in fact, to replace the necessity of having a human doing this task. And so the actual interface will be like the next person in sequence or the next position in sequence in this business process to interact with it and to be able to expect to a certain degree higher quality output because it was done sort of mechanically compared to a bored human.
Yeah, so I also agree with, I agree that the user needs to be, the user doesn't care how something works, right? The user just wants this thing to work. But I do also agree that it's important to communicate to the user at what stage you are with your project, right? So there's core functionality. The user's just going to expect that this works perfectly or near perfectly. The search, recommendation, like all these basic technologies, the expectation is just there. Then you're going to have a bunch of projects that are more experimental, and for that, you do want to slap on the beta label, like I mentioned earlier, just so that the user knows this is not a perfect technology at this point. This is like a gimmick. You can try it out and see if you like it. Right? To give one example, one thing that we're working on is something called Street to Shop, where you take a picture of an item of clothing that you see outside on the street, I guess, or a shoe or somebody wearing something, and then the software detects for you which products are in this image and gets you direct links to the Zalando shop, right? But this is not super, so I'm just advertising a little bit, but it's actually not broadly advertised because it's very much beta. So it's just a gimmick at this point that we're working to improve, right? But it's very important to communicate this clearly so that people don't have unrealistic expectations. Right?
So I think these answers are quite interesting because I think this actually slightly mismatches with, I guess, the conclusions that I've come to about this. And I guess I think that even if something's tooling and people are interested in getting the result, software and other types of tools I think are actually quite difficult to use if the user can't build a mental model of roughly how it works. And so, you can imagine kind of helping somebody who's kind of a new computer user and how nervous they are about making any actions on the system. And one of the things that promotes that nervousness, I think, is not knowing what matters and what doesn't, and not knowing how to reset themselves to a state where they're, back at kind of a clean state, and knowing that nothing has influenced it from before. Like, closing a program and opening it again roughly should reset you to the beginning of that program. But I think if we're working with predictive technologies and the user doesn't have that sort of model of how the thing works, then it does become quite difficult for them to kind of use it in this way. So for instance, if they're using a chat application, does the chatbot condition on all of the previous conversations, or is a new session a new session? If the what type of mistakes might have been made in the interpretation, and if that does happen, what can I say to it to kind of interact with it, and get it out of this state? So maybe my perspective on this is different because I come in as the author of some of these systems, but I guess I would, I'm always trying to figure out something about the mental model behind this, and I do think that can make these technologies easier to use. But on the other hand, there's different users have different applications and things. So one of the other things that I wanted to ask about is, if we talk about natural language processing, especially from the research community, there's an enormous emphasis on English language processing, right? And actually, I think the emphasis on English as opposed to other languages has probably increased over the last couple of years as we've had a wealth of new toys to play with, and naturally people tried out on English first. So I wanted to ask you whether you saw a gap in how easy it is to process English versus other languages, whether you think it's different capabilities and whether you think this will change and other languages will catch up quickly. So, Alan, do you want to start with this?
Yeah, absolutely. So there absolutely is a gap. So English is by hands down the most researched language. So all of the NLP stuff, all the text analytics stuff that you guys want to do, it's going to work way better for English than it's going to work for any other language. So most of the natural language processing community has focused on this one language. And as a result of this, most of the data sets that are available are actually for English. So if you want to train your systems to do whatever, you need a big data set of high quality data. And I'm actually going to talk about this in the talk, so after this, so stay if you're interested in multilingual stuff. But yeah, so that's a big problem. And so it's not that easy to take something that works for English and just apply it to, let's say, German. If you want to do some sort of text analytics for German, many times you have to create the data sets yourself, which is a huge amount of effort. You might find that the approaches that work for English actually don't work that well for German. I actually have some examples of that in the presentation. So there is definitely a huge gap, and people need to do, especially we're in Europe, right? It's super important for any company that operates in Europe to be able to understand all the major European languages at least, right? Because the customers are going to speak all these different languages. And this is maybe not so important if you're in North America, where basically everybody speaks English, but the European situation is special. So you do want to absolutely invest time in that. Yeah.
Yeah, I do agree that there are differences even on several levels. I mean, there is, apart from the endeavor in figuring out what is actually been said or what does the said mean, there is also the nuts and bolts of everything. So you need to parse text, you need to know how that parsing English is different from parsing German. You have these compound nouns, you have languages like Thai where you don't have spaces anywhere. So you have in every language specific cases that you have to be aware just to sample the text properly. And the next thing is, of course, that most of the current approaches in trying to make the meaning tangible are based in some way or the other on statistical models. So you have to train on data that actually represents the statistic in a specific language. Or the other sort of state-of-the-art approach is to use a rule-based approach, which again obliges you to adapt the rules because they mostly depend on things like grammar, and grammars are different across languages. So that's, by the way, the reason why we try to find a more fundamental aspect to this by actually focusing on representation, because the representation of what the word cat means inside the head of the perceiver should be the same for an English speaker or a French speaker. So it basically boils down to the question, what representation of language elements could we have that sort of becomes language independent, and that's basically what drives our approach in the work.
I will agree with all of you. Certainly there is a huge gap between English text processing and all the other languages. Well, some languages are more advanced in terms of having resources about analytics, but mostly this is a big problem. I would have to also say that we need reference material, data sets, and also the thing with grammar is that we do have differences, of course, but we do have some common elements. But even these need further work on that. And the thing with the European Union now that we have this vague status of English with the Brexit thing, this creates a lot of let's say, turmoil in the language environment, because many resources are in English, and now English is somewhere up in the air. But yeah, we do need to find ways to develop resources, natural language resources for other languages as well, especially Spanish, for instance, which is a big community, and other languages as well. I think that we need to maybe reapproach the thing, because I know many companies that rely on machine learning to develop NLP tools for languages they don't know, they don't understand, they don't have native speakers inside. And I think this is a bit problematic, because we should not forget that machine learning is a language agnostic technology. So you cannot rely on a language agnostic technology to process language. There is an inherent controversy, I think, here, and we shouldn't lose sight of it, because we may end up with weird situations in the years to come.
So the idea of the language agnostic technology, you know, on the one hand, machine learning is also, you know, image agnostic, but it seems reasonably reliable at, say, recognizing, you know, the digits of handwritten digits or some other types of images and things. So, you know, we've so far been discussing relatively knowledge-intensive approaches to NLP, which I guess is the sort of more traditional approach, or the approach that's been established for longer. But more recently, there's been increasing interest and also increasing success in quite low knowledge, high machine learning approaches. So for instance, it's possible to have a machine learning model that operates on a per character basis, right? Or just even per byte basis. And so there, it really isn't acting, it has to learn the whole abstraction level of language. And so there you might say, okay, assuming that the language has a writing system, that this is sort of reasonably language independent. So given that this is starting to work at least a little bit, and people, you know, might forecast that this is kind of increasingly working, how do you see the advantages of this sort of very low knowledge approach of just having a purely machine learning approach of reading something even at the character level, where you don't even have to add word level information? So Mara, would you like to start with that?
If you mean that eventually we'll reach a point where we won't need humans or other type of science to develop NLP besides machine learning, then I certainly hope that we won't get there. I mean, I'll give you just, I'll share with you something that I heard recently, which is something like what we're discussing. It was about a case in a family where the mother used to talk to Alexa in a very specific way, like giving orders every time she wanted something to be performed. And the two children in the family unconsciously keep hearing the mother talking in a specific way, in that specific way. And eventually, they started talking to each other like that. So there are very fine limits on how well we understand what it means to rely solely on machine learning or any type of technology in our everyday life or even in our business life. There are many dangers inherently there. So unless we're really pursuing hybrid systems where we take advantage of humans, because humans should be at the top of everything we do, in the future, in the present, and unless we keep that in mind and we use all the wonderful technologies like machine learning, deep learning, and whatever may come in the future to serve humans and keep in mind what it means to behave in a human way, the difference between please, can you do this, instead of do it. In terms of NLP, maybe it's more practical to give orders, but then we use quality characteristics that matter even in text analytics or in speech analytics in a way. So I believe in hybrid systems. I believe in the human being on top of everything. So yes, machine learning has a lot to give, and I really hope that we'll be able to exploit it, but let's not lose sight of who we are and where we want to go.
Yeah, in my opinion, I actually don't agree because I mean, with your proposition, because I don't think that machine learning works particularly well in natural language processing. So if you go out and you try to find practical implementations of some of the gimmicks that you can see on the research side on some toy problems, where actually this enthusiasm mostly comes from, in the real world, you don't see those systems. Yeah, most NLP systems that are used in a commercial context are typically carefully crafted statistical modeling systems that where a lot of effort has gone in, with a lot of experts that have been involved in this. And it's even among implementation specialists, they keep saying that their worst projects are actually NLP projects, because when they start doing something, they never know how long it will take. They will never know how well it would work in the end until they have done it. And if you throw something like machine learning into this, where even if you are successful in solving a certain approach using, let's say, deep learning, you can't even say why it works. Yeah? So in the worst case, if it actually doesn't work, where are you going to adapt or improve anything if you can't explain why this whole thing is supposed to work in the first place? So in my opinion, the actual problem is not so much the language as such, it's the understanding of the intent. That's where sort of the advantage is. So I'm not so much worried about how elegantly we can sort of handle language, but how well can we allow the computer to understand information that we humans use to encode in language. So I'm, for example, a very strong believer that in not so far future, you will get a better medical advice from a machine. For the simple reason that a machine is capable of ingesting basically even a paper that has been published this morning can become part of the evaluation of what diagnosis and what therapy would be relevant. So I usually, when I try to be controversial, I say in 10 years' time, I will go only to doctors that are machines and not to humans anymore. But you can find many different areas, and specifically when I said before, humans perform extremely well if they are bored and if they don't like to do the kind of activity they do. And if you look in the professional context, you see that most of what we do is actually, in a professional environment, is actually boring. So we would want to get rid of these kind of activities and focus on things that sort of create a positive feeling in us. And so I think we shouldn't be so much afraid of actually dropping certain activities. I mean, it has been perfectly normal to say it is an inhuman task to put a person in front of an oven of 700 degrees and to work with some liquid steel. Nobody wants to do this for 30 years anymore. Yeah? And there are many other activities that we do today in our offices where maybe in 10 years people will say, I can't imagine that people could do this for the whole day. Yeah? But there are plenty of things that are still relevant. So I don't think that this is something negative, but it's just getting rid of stuff that you don't want to do and try to find a more sort of automated way of doing this. And that's what I think at the core is the task of the next sort of generation of natural language processing.
Okay, so yeah, I would also agree. So I am, however, a lot more optimistic about neural networks. So it is true that a lot of the installed systems in big companies are, of course, legacy systems that come from a time when deep learning is very new, so, or at least in its current incarnation, it's very new. So people haven't been building like these huge industry systems with it for a long time. And so, of course, the installed base is going to be old systems that have been handcrafted and hand-optimized for, I don't know, 5 years, 10 years. And it's hard to beat those systems also because people know what they have. So don't expect these systems to change overnight soon. But deep learning is actually extremely useful. So you mentioned in the beginning character-based models for NLP. Character-based means essentially that a sentence is read not word by word, but letter by letter. So these neural networks actually go through the sentence letter by letter, first learn by themselves what is a word, and then learn what they can do, what these words mean in context, right? And the big advantage, going back to the multilingual stuff, is that in this scenario, you don't have to do feature engineering. So all the stuff that people used to do, when you read old NLP papers, and by old I mean like a few years ago, they would always be like a table this big with all the features that they handcrafted and hand integrated into the system. And now all of that is gone because the neural network learns all of it by itself. So no more feature engineering for the most part. I mean, you still have architectures, but the actual feature engineering is gone. And so if you go online and you want to have a state-of-the-art NLP method, it's actually not that hard to get there. You just download the code from some researcher, you run it, it's not that big, it's a couple lines of code, and it'll give you state-of-the-art accuracy. So I'm actually very optimistic, and I think in the future, as soon as these systems really start beating stuff that rule-based systems can't do, we're going to see a lot more of this kind of stuff.
Can I give an answer
yes,
to this?
certainly, yeah.
That's very well, and I mean, I don't say that neural networks don't work. What I'm saying is that in practice, you have situations where it's very hard to use them. So you're right. I mean, you can even take a character-by-character sampling, so to say, to avoid feature generation. So the whole reason why there is something like deep learning is because we wanted to automate the feature generation. My point is, you need a lot of data to do this. So, for example, a customer of ours who wants to monitor email communication between their employees and their customers, and they want to make sure that there is no inside trading, like you need to buy this because I know that company's stock will go up. And we have been sort of competing against a couple of deep learning approaches. And after the POC, they said, okay, if you could give us 300,000 of these fraudulent emails, then we can solve your problem without any interaction. The point is, if a bank has 300,000 fraudulent emails, they're probably out of business. And that is a core problem of deep learning, is we are swamped by data, but still we don't have enough data to sort of find automated solutions for certain text problems. And so we need solutions where we can have an approach as with humans, where we say things once, we maybe say it twice, but then we suppose that the person actually gets it. Yeah? And that's the kind of machine learning where we need to go to. Yeah.
I would like to make a remark as well. I totally agree with you about machine learning requiring too many data to get trained properly. And the other thing that I see as a problem in machine learning is that it has no cognitive aspects in the way it makes a decision. So I would like to see in the future, at least that's what we're trying to do, is a way, hybrid systems that beat these two failures, let's say, of machine learning. How to reduce the volume of data that machine learning requires, or deep learning in that case, to get trained properly, and how we can make it clever, because now it's not clever. It just matches patterns, which is problematic when we're talking about quality features. Quality, I mean, many companies come to us because they want to find out things about the people writing stuff. So you can't have this type of information when you rely solely on machine learning, because you have no context whatsoever, no expert knowledge, no human features in the analysis. So we should try to get together human approach processing in machine learning. So I think that would be really cool.
So in summary, I think the interesting state that we're at is that the benefit that you can get from, say, a character-based neural network model is that you don't have to do feature engineering. But the very real downside is that you don't get to do feature engineering. And that's actually a very significant disadvantage, because you're in this position of knowing what's important and knowing that, say, some aspects of the problem are over there because, you have this knowledge, or the experts that you're working with have that knowledge. And so how do you get that knowledge into the system? Well, one way is to have enough data that you don't need to, that it's all inferred automatically. But if you don't have that, then, and you've kind of set the system up in this way where it's going to learn this all from first principles, then it becomes there are ways to actually sort of guide it towards the solution that you think. But if you're taking this neural network approach, suddenly the sophistication statistically that you have to do to get that sort of effect is quite difficult. And so I think we are in this slightly, things have gotten slightly worse in many ways before they get better, because in practical terms, there is this difficulty of teaching this system even basic things that you kind of know because you've set it up to learn everything from first principles. And so I think that sort of explains this effect that we're seeing where, in theory, everything should work, but in practice, we still have this gap between, how things should work in future and what's the most practical approach for a specific problem right today. So I think...
just to become even more controversial, I think that we now take it for granted that when we do NLP, we end up doing feature engineering. I just would want to discuss the point, is that the only way of processing information that people have in their heads? Because the point is that feature engineering basically comes into play if you try to do statistical models. And my claim is that at least we humans don't do anything by statistical models. If you test humans, they tend to be pretty bad in predicting statistical properties whatsoever. Yeah? So we have obviously a different way of doing this kind of information processing, and I think that this is completely different from statistics. And what we see today is that everything we do basically in machine learning is based on statistics. It's sort of a brute force approach. And that approach works better if the information that we handle is already to some degree semantic. Yeah? So it's not, to me at least, it's not astonishing that, for example, deep learning works pretty well on image data. Why does it work well on image data? Because there is a lot of statistics captured in the representation of an image. If you have two pixels that are close to each other and they have, and those pixels have the same color or shade or so, you can assume that they come from the same object. So you have some interpretability of the scene that is represented. But we are far from having this semantic encoding in whatever features we come up with language representation. And that's, I think, where the actual problem lies. So everybody is looking at the algorithm. We are looking for the algorithm that starts to be intelligent. But I claim the algorithm was clear from the beginning. The algorithm is comparing stuff. Yeah? That's what we do constantly. We judge about things by comparing things to things that we have seen or stored to some degree. The question is, I think, how do we do this? How do we represent the meaning of cat in our head? And once we have solved that, I think many sort of downstream issues we have will be much easier to understand.
Just one.
I think are we out of time, or should we continue?
Definitely.
We're out of time.
Okay, yeah. Yeah.
If you have more questions for them, you can definitely talk to them later. No worries.
Yeah. Okay.
Sorry.
One round of applause for our panel, please.